So I hope you have had a great lunch and are well fed. Well, we notice we have the Day of the Sebastians. We all noticed that. So next up is the next Sebastian. And we oh, okay, that's just doesn't look like you. Sorry for that. But it's Sebastian. He was here last year. You talked about Git. I remember that. And I actually learned something, so that's cool.
That's good.
And I use some of your tips quite a lot already. So the one thing I took with me. So I am excited to hear what you have to say today. And if I will tell you next year, when you are probably here again, what I will learn then.
If you call me, I will be here.
That's great. So give it up for Sebastian.
Yes, hello everybody. So hope you enjoyed the lunch. And so now I have to get you out of the food coma thingy. So this talk will be, as it says, yet another microservice talk or tale. The thing is, I will be very blunt about some things that you will see on the slides. If you recognize things that you have done, are doing at the moment, or plan to do, and I say words like stupid, dumb, bad idea, I don't want to offend you. So this is this is basically a journey that I am on, or was on, or still will be on for the next couple of the unforeseeable future. So as I said, don't be offended or anything. Just I will try to make you laugh or maybe even cry a little bit. So let's see how that works out. Okay. So I'm the last Sebastian for today. So I promise no more Sebastians after me, right? And normally I don't do this because it always shows you how old I actually am. So I don't update the slides anymore. I always say that it's roughly 30 years. But since Sebastian did it, I have to, it's basically Sebastian since 1977. So, okay. Yeah, you can toot or tweet or X at me. I try to react on that stuff. I do a little bit open source on the side, and yes, I'm the proud father of the Jeffrey elephant. But that's not what today is about. So, I work at a company that over the last couple of years grew quite a lot. Right? Some people say it was a little bit crazy, and from the inside it was. So when I started, we were just a couple of developers. I would say 50, 60 maybe. Right? Over time, right, that changed. Today we are over 2,000 software developers in that company. And most of the stuff we developed over the 10, 15 years the company exists, or even sometimes 20 years, we created in Monolith, because that was what you did back then, right? That was the thing that everybody was doing. And just to be clear, I'm not suggesting 2,000 software developers work on the same project in the same Git repository or the same monolith. That's obviously not true. That's not the case. But nowadays, I would say when we talk about products in terms of our company, we're talking about 40 to 150 developers, something like this. Sometimes a little bit more, sometimes a little bit less. Depends on the product we are building and the circumstances and everything. And we developed that monolith for a very, very long time, right? And the company grew, and we had to scale the monolith, right? And that's what we did. We scaled it. Like it was like we just run it multiple times. We went to main and replica stuff for our databases. We put caches in front. We used like tons of different stuff to scale our monolith. It works. Like if somebody tells you you cannot scale a monolith, that's a lie. Like if somebody comes to you and says we have to do architecture X because we have to scale, always be a little bit, are you sure? So the problem was never scaling. Like we could scale like crazy. Right? It was not an issue at all. Like, or it was challenging, of course, but still, like it was doable. Like we could scale. Basically, we had a different challenge. So the challenge was that our monolith inside looked like this. They were actually a big ball of mud. So the problem is more like, okay, how did we get there? Why did we have this big ball of mud that was really not maintainable anymore, right? Like the feature pace slowed down. Like we more often broke things. When we added new features, we broke stuff, right? For us, we thought it was totally unrelated, but of course it was somehow related, but we couldn't see that. So we more and more often broke things, and our pace was slowing down. And that's always something business doesn't like, if the pace is slowing down. So the question was, how did we get there? What was going wrong? And the first answer is like, because we can, like that's like how it works, right? The more detailed answer is nowadays when I think about a software application, you can approach it like a buffet, right? And if you are not into candy or sweets, most likely you enjoy something like this a little bit more, right? That's if that's more of your thing. But let's stay with the candy buffet for now. So what do I mean with buffet? It's pick and choose, do everything. Right? You have the whole application in front of you because it's one single application, it's the monolith, and now you can basically pick and choose. You can do whatever you want in it. You can connect everything to everything. And if somebody says something like that to you, that should scare you. Like if I can connect everything to everything, that's already bad, right? But this is how we work, right? So we sit in front of our application, there's maybe some ticket or some task is coming in, we are seeing it, we're trying to solve it. Okay, what do I need? I need some of this type search, I can use this seems to work, and now I need some other thing. This over there, okay, now it works, and now I have put them together, right? And most likely I should have never done that. Right? Because it's bad to introduce those kinds of dependencies. But since we see the whole application in front of us, we just do it. And this is how we solve problems. And there's nobody actually walking around and screaming at us and you should never connect those two things, because very often those rules, like what things you should connect to each other, they are not explicit. Like maybe some people in the company don't even know them. Maybe the business has never told you that those rules exist, right? But because we never asked. We made assumptions and stuff like this. And this is just how life happens, right? So this is where we were. Like we had this big ball of mud. And this is actually a thing. Like when people talk today about monolith, they immediately think about this huge application that is like basically spaghetti code, the big ball of mud that's really bad. So people think the monolith is bad. And that's what kind of made us think what we should do about it. And then, of course, a couple of years ago, this started to get really, really popular. Right? microservices, the holy grail of software architecture, right? This was like, do this, it will solve all your problems because everything will be completely independent. You will not, like, you have clear boundaries in everything and everything will be amazing. And I say, sounds great, let's do that, right? So that's what we did, right? And of course, there's a lot of like literature out there. There are blog posts, videos, and you can go to conferences, and they will give you like strategies how to do that. So, and we followed those strategies. We strangled, right? That's what you should do. Like, we should identify some functionality, and then take that functionality out, right? And that's what we did. We identified more functionality, and then we moved it out. And over again, we did always the same thing. We identified functionality, we strangled it, we moved it out, right? Until we kind of had something like this, right? Yay! We successfully microserviced. At least we microserviced. Like, this is what, like, we microserviced, okay, nice, we did it. So why wasn't it successful, right? The thing is, we had everything perfectly set up in microservices. We had separate teams and even microservices in different technologies, and it was basically Wonderland, right? So, but the feature pace didn't increase. It basically got worse. And business was not really happy because, of course, we promised the world to them and said, like, look, if you have microservices, it will all be wonderful. Like, we will be fast. It's only small problems at the time that we have to solve. But yeah, when we look at microservices in a book or in anything, when you look at the diagram, how microservices should be set up, it is something like this. Right? This is how the communication should be structured in that kind of architecture. That wasn't true in our case. And this is something I see actually really often. Like, you have microservices calling microservices, calling microservices, calling other microservices, calling actually a microservices that it was earlier in the chain already, right? Just to get some information. So we had call circles within this, and those were in a way on a synchronous calls happening. They were happening on synchronous calls, and like we had, and you have to understand something. As soon as you distribute, you are not improving the speed. Like, it will get slower. That's just a fact. It cannot get faster. It just can't. Because network is way slower than memory. It just is. If you can do that on the same machine, it will be extremely fast. If you have to distribute, then it will get slower. If you distribute, then it will get slower and slower and slower, right? And this is what happened, right? So today I can't call this microservices anymore. This is basically a distributed monolith. And this is, trust me, this is the worst place you want to be in. You don't want to have this kind of architecture. Distributed monolith is basically this. Like, you had a distributed ball of mud. So a lot of small balls of mud. And the problem is that you don't see it like this, because when you look at the microservice, you created it 3 months ago, like you used the latest framework, it's nice, you had PHP Stan running on the highest level, and it works, right? You have everything unit tested, it's wonderful. But no, when you look at it from a system perspective, it's a ball of mud, or it's part of a ball of mud. It's a very nice part of it, but it's still... It's still it, right? So, like, this is basically the worst thing you have. You have an entangled ball of mud now, right? That's really bad. So, When we look at the scale, right, we have this thing where we go from a centralized system to a distributed system. Right? We were on the ball of mud side. We just took that and distributed it, and it was not a good idea. And the thing or the problem was that most of the time what we did is we just looked at technical functionality. We said, okay, this technical feature is something that we can do by itself and that we can do somewhere else. And that's how we approached things. We said, okay, this is something that makes sense to, or this is small enough so I can actually figure out what to do, and then I can extract that. Right? But we never looked at it in terms of from a business point of view, where we can actually see, okay, what kind of use cases do we have, and how is data flowing in our system, and what kind of connections do I really need at the same time, and what kind of connections don't I need? Right? So we had to, in order to fix it, we had to create a second axis. Right? We had to go from centralized to distributed, but also from coupled to modular. Right? We wanted, so we don't have everything really tight together. Right? When we basically made the decision to distribute into microservices, we violated the first rule of distributed computing. The first rule of distributed computing is don't do distributed computing. Because it's really hard. Right? And so this is where we were, and we said, don't do distributed computing. We can do this, right? And we said, okay, how can we fix the problem? So we doubled down, and we said, okay, let's fix this, right? So we introduced an event bus. And now, like, everybody is just talking. Like, this goes away. Nobody is talking to each other anymore. This is perfect. This is the problem we had, right? So now, everybody is just talking to the event bus. Like, we are just putting things on the event bus, and people are listening to the event bus, like pops up stuff, and it's amazing, right? This is where we want to, like, we said, not distributed monolith anymore. Now we are actually in event-driven microservice architecture. And of course, we didn't do this like 2, 3, 4 times. No, like, trust me, we did this like very, very often. And the thing is, right, what we actually did, like, we didn't fix anything. We just hid the problem and said, nobody can see this anymore. Like, you can ignore problems like this. Like, no, it's not me. Right? It's not me. Right? This is not a problem. But eventually, it will. At some point, it will catch up to you. It will bite you. Right? And we still had the same problems. We still had indirect dependencies because, of course, just because we're using in the event bus as an intermediary, the connection is still there. Like, there's still the dependency. And sometimes we still had those dependencies in synchronous requests. So we were waiting, making a web request came in, right? And we threw something on the event bus, and then we were waiting until some event pops up, and then we said, okay, that's the result, and then we could give it to the customer, right? So that's also already like a bad sign that's not the right approach in that case. So not a good idea, right? So we actually didn't have event-driven microservice. Now we had distributed event-driven monolith. And I don't have like a nice fancy drawing for it, but it's slightly worse than the distributed monolith already. Right? So this is where we were at. So how to fix it? Like, where did we go wrong on that thing? Right? And as I already told you, the problem was we connected the wrong things together. And we extracted things that maybe shouldn't be extracted. We just made our system in a way that it was solely focused on technical things. Right? And Sebastian was talking about domain-driven design. And he thinks about like the technical aspects of it, like repositories, entities, value objects, the kind of how do we implement it. But for me, the way more important part is like domain-driven design means we should focus on the business, on the domain that we are building. Like we should actually look at like the use cases, the problems that we solve and solve them accordingly, right? And those use cases and those boundaries that the business defines, those are the ones we actually have to implement, right? And this is, for me, nowadays, it's the hardest part in software development, right? Like, teaching people how to write good code can be done, right? You can give them books how to write less, like you teach them how to write code with less cyclomatic complexity, with higher type density, and more functional approaches. You teach them immutability and that kind of stuff. You can teach that. But the really hard part is really how do we model our system? How do we define our boundaries and how do we connect things together? That's really hard. So what we and the thing is, this is most of the time, like we will most likely get it wrong, right? That's just how it is because stuff changes, business changes their mind, some stuff changes, and we have to follow along in our software. But you have to understand, as soon as you distribute boundaries, like you create network space as a boundary, that's really, really hard to change, right? Changing network boundaries back is hard, right? So what can happen here, right? We thought it's like this, like the thing calls some functionality, and we said, okay, we can extract this, right? But in reality, it was actually like multiple places in our application we're using this. Like it's not just one thing, right? And so there are basically two options now, right? And depending on how the business, the domain works, we have to do either one. So the first thing can be that our extraction was too big, right? We extracted too much, right? And then we should basically we should have extracted three different things, right? So we have, okay, this part of the application talks to this part of the application talks only to this. This only works, right? This only works if we don't have that type of dependency anymore. Right? If we have this kind of dependency, because the small things now have to talk to each other, then it was the wrong one. Then it's the second one. Then the boundaries were too narrow, and we have to increase the boundary. Like we have to make the chunk that we cut off maybe a little bit bigger. So we can maybe take that part, right, and move it over to the right side and say, okay, now this is bigger, right? The thing is, that at some point, the word micro was never a size definition. There is an architecture called service-based architecture, right? And to not confuse it, we had to come up with a different name. I'm not saying software developers are really good at naming, so this is what happened, like micro, and now everybody thinks, okay, it has to be really, really small. No, sometimes it has to be bigger because of the dependencies, right? And there are other smart people that say something like this. We overemphasized micro and misunderstood service, like Jimmy Bogart. And misunderstood service means service is not a technical thing. It's a domain thing. It's a use case thing, right? So we have to find the boundaries in our application. So how do we do that? So let's assume we have, this is our application, right? So we have the UI layer, domain objects, repositories, and a database. And I would say nowadays, this is a solved problem. We don't have to worry about that anymore. Because as soon as we use a modern framework, or any framework, like you pick your poison, right? It basically forces you in that kind of structure. Right? It makes sure you don't have database queries in your UI layer, right? Like you will not see database queries in Blade templates or anything. Like I'm not sure you can write something like this, but it will never show up in the documentation, hopefully, right? So for me, this solution or this problem is basically solved. Like we have now separated our business logic from our presentation logic and from our storage logic. Right? What we should focus on when we develop software is modules. And I really like that Sebastian talked about these narrow and deep modules and wide and shallow modules. Like this is basically the same concept, right? We want to create these kind of things that handle specific use cases. And in best case scenario, they will never talk to each other. Right? There's no communication from left to right, right? And sometimes they even don't use the same data, right? Or best case, they don't use the same data. Right? That's the perfect thing about it. Right? But of course, that's utopia, right? That's like it looks nice on the slide, but like we have like it's the real world, and we are writing software, right? So of course this is not. But the thing that you have to like watch out is. When I talked about the buffet, right, and everybody could grab everything. Oh, there's a muffin, that looks nice. Oh, some, like, I don't know, creme brulee, yummy, yummy. Right? The thing is, when you have your modules, right, you have your modules, and basically there's a chef that's guarding this module and is having all the nice things that are in there, and nobody can talk to them without talking to the chef first. That means you have to have an API around the module, and you are not allowed to instantiate an object from within that module willy-nilly whenever you want. Right? And this is perfect because Andre just showed us how we can make sure that nobody does that. Like we can write a custom PHP stand rule for this. This is amazing. Right now we can make sure that it doesn't happen. So every module, like if you have to talk to it, like it must have a clear API, right? It must have like a couple of methods or functions that you can talk to, but you are not allowed to grab into that thing and do whatever you want with it. That already sounds a little bit inappropriate, right? And it's the same thing in software. If things in real life sound inappropriate in software development, they maybe are as well, so we shouldn't do them, right? So how can we fix something like this, right? So if we have one-way dependencies like this, right, and it's not only one place where we have this, right? We have multiple places that always talk to the same three things, and those three things appear in multiple places. We can just put an intermediate in between and can say, okay, now not everybody has to talk to three things. Maybe everybody has just to talk to one thing, and that makes sure that everything behind that works. Right? So put a barrier around it and say, okay, now we are only talking to the purple thing. Right? That way, you don't have these weird or always like the triple as much dependencies. It's just one dependencies, and then only one single place depends on the three boxes on the right side. Then it can have that we have strong dependencies, right? Where things are talking to each other all the time. Like they are calling each other and exchanging information, and it happens all the time. So when we have something like this, it's a very strong indicator. When we have a strong dependency, they should be together. Like they shouldn't be separated. They should basically come together. And this is something that is a general rule for software development, I would say. What we strive for is low coupling and high cohesion, right? And low coupling is easy to, I always got it. Okay, if I don't have any other dependencies, then I'm totally decoupled. Or if I can do stuff by myself, I'm decoupled. If it has one single responsibility, it's decoupled, right? But cohesion was always something I struggled with. It was even hard for me to explain it when somebody asked me, okay, but what does this cohesion thingy means? Right? Cohesion means that everything, like if you have a thing that changes, and after that change you have to change 5 other places, they should be together. That's what cohesion means. That's what depending means. If you change this and 5 other things have to change, they should be together. Right? That's cohesion. That's when you put stuff together. If you change something and other stuff doesn't have to change, that means it's not cohesive. Like it doesn't reflect the changes that you made. Then you maybe can extract it. That's basically the benchmark, right? Where you can think of, okay, I can extract it, right? So always strive for low coupling, high cohesion, right? That's basically the idea. And you can apply that on every level in your application, like from writing very small tests and running unit tests, and your unit tests will tell you like if you have high coupling, because if you have highly coupled code, what you have to write most of the time are chicken tests, right? Because you have to set up your mocks, like mock, 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 mock. And then do one single assertion, right? Those are really bad. Okay, come on, no. Right? So, as I said, it goes from the very small parts of your code right to the overall system architecture, to your complete overall system. Try to decouple the right things, right? And always look at it from a domain perspective. And an issue that sometimes we have is that we have model dependency, right? Where we think, somebody asks me, yeah, we have this 5 microservices, and now we have to, like, how do we share the model? Do we build a library that, like, they are all using the same model? And I say, what? Like, that's weird. Like, why do you want to do that? And sometimes the problem with modeling is we put things, again, together that shouldn't be together, right? And to explain this a little bit further, we do an experiment. Can you identify what this is? Like, I drew those myself, so I just wanted to ask, like, what is this? Tomato, yes, perfect. Okay, now we are on the same level. So, a tomato could be a fruit, right? If you ask science how to define it in a genetical level, it's a fruit. Like, if you ask a chef, it's a vegetable. Okay. If you ask some time management specialists, right, it could be a unit of time. So maybe if you know the Pomodoro technique, it's a unit of time. And if you are maybe working in theater, it can be a form of feedback to you, right? So, and this is what modeling comes to. Like, we see, oh, this is a tomato, cool. Let's build this in code, right? So we have a class tomato. So we get the fruit DNA, we provide feedback to a person, we make soup, and we start some timer. Like, we put everything in it. Because for us, it's a tomato. And this is what a tomato should do, right? And like in this example, I hope it's obvious that that's not the right thing to do. But even if we have something like a user, right? We put every logic we have into this user thing. Like sometimes we have user classes that are like 500, 1,000, x thousand lines of code, right? Because all the functionality for a user goes there because it's called user. We name this thing user. And then you have to think about, okay, how can, like, where's the modeling issue? The modeling issue is like we should think about what kind of use cases those models solve. Like maybe we have a user where we can only read data, like that we can give around, that's immutable. We can give that thing around through the system completely safe. Maybe we have a user that's used to display the user profile where all the information is in there, right? Maybe we have a user where you can actually change data, like where people update their profile or anything, or maybe an admin checks. And we use different models for this. And we give different modules access to different models. Right? So for me, it's not a problem if I look at a code base and I see like 10 user classes. I think that's actually good, because I assume that those user classes all have different purposes in my application, and they are modeled in a way that they don't interact with each other. Like they don't have to change model stuff. Right? So we really want to model it in a way that we have a thing by itself that just says, okay, this is what this has to take care of, right? Separate functionality. This is what we want to achieve, right? And if you identify those vertical things, right, and those modules, right, and then sometimes you have to combine them. Right? Sometimes you have to move the boundaries around. Right? You made the wrong assumptions. Very often, at least in my case, software development is making assumptions or educated guesses, sometimes uneducated. And so I have to learn on the go. I have to be able to make changes. I have to be able to fix my modeling, to change how the boundaries around things work. I have to be able to change APIs and all that stuff, right? The important thing is that if you go there, every module has to have its clear defined interface how you talk to it. Right? Like there shouldn't be any way possible to reach in there and just grab something out and do something, right? So when we are talking fixing the monolith, and I don't think monolith is a bad thing. I really like my monolith. I really do nowadays, right? Because I don't distribute my problems. I still have all the problems in front of me in one single application. And I can basically do this. I can build a Modulith. I can have everything in one application and eat my cake too, I would say, right? The rainbow cake. Right? The thing is, when we start our journey from like an application and we want to distribute it, we should be very, very sure that the boundaries in our application are actually in a good position. The boundaries should be very, very clear, because if we have the wrong boundaries and we distribute, like again, imagine if you have to change the boundaries, like you put too much data, too much functionality over there, over the network, and now you have to move it back. Like this, like if it's in a monolith, you just say, okay, fine, change some code around, okay, maybe even fix some SQL queries or something, compile or like hit, and it works. Okay, cool, I can deploy this, right? I'm not saying it's easy, it's like still a lot of work, but it's like for you can figure it out in a certain amount of time. If you do this in a distributed architecture, what you have to do is you have to change maybe an API upwards and downwards compatible, deploy some other API upwards and downwards compatible, then make a migration of data from one to the other, then make sure that the data is written in basically both positions, then at some point say, okay, now we only use it back in the new area, the old actually, and then we deploy the upwards, downwards compatibility stuff on either side. Like maybe a day project becomes a 2-week process to actually get this done. And people don't do that because it's hard. And then they live with those messed up boundaries, right? And they just live with like how everything is connected weirdly, right? So I can only try to encourage you, when you're really struggling with a big ball of mud, right, try to go this direction first. Right? Try to build a modulith. Try to identify modules. And it's basically the same concept. Right? It just means you have separated code, right, that only is accessed through an API, HTTP call, okay, nice. And nobody can touch the stuff inside, because you cannot touch the stuff of a microservice. Like that's why they became so popular, because we cannot do this kind of weird entanglement. We kind of did it on the network then, but the thing is, like when you do this, when you follow this microservice approach within the monolith, right? Then you get to this Modulith, and then you maybe can make the decision. I don't have to distribute this. This works fine. This is cool. This is now maintainable. It's nice. It's completely separated and isolated, right? And it works in my application. Cool. And if you make the decision that you still want to distribute it because, and there are not many, but there are good reasons for distributing stuff. Like when you, for example, say, okay, my monolith, like I don't want to scale it completely because only this small part needs to scale, because this is where our customers really like put strain on the system, and we want to like scale them separately. That's a good argument to actually like distribute stuff. And then it's easy because you already have the boundaries. You experienced what it means to have the thing basically completely isolated, because it's already isolated in the Modulith. And now what you can do is you can basically take that code, put it somewhere else, put an HTTP, I don't know, interface in front of it, map your API, your class API to some HTTP calls, and you're basically done. That's all you have to do then. Right? Extracting a module from a monolith into a microservice is actually like totally straightforward. Right? So this way is really, really nice, because it's basically already done. The only thing that you have to make sure that works is the HTTP stuff. Right? Already a solved problem. Right? So don't go this way. Like it's really, really, really hard. Right? It's most of the time ends up like this. It's like, that's just how it works. I'm not saying microservices are bad architecture. Microservices are a really, really, really good architecture, but they are really hard. It's the Champions League of architecture. And if you think you can like strap on some football shoes now and go and play in the Champions League, be my guest, right? There's a lot of stuff that you have to do, right, to actually get to the Champions League. Like a lot of training, physical, like your health, like what you eat, like training facilities, all that kind, I don't know, like tons of stuff that you have to be really, really, really good at to make that work, right? And so try to like not increase the complexity by a 1,000-fold and going there, right? So when I look at systems, I have some red flags, right? So where I say, this doesn't look good. And the first thing we already talked about is like shared models. When different services distributed over the network basically use a library or something to use the same models, something like this, right? And now we can talk about the actual rule, or the actual first rule of distributed computing, right? That's Martin Fowler saying, don't distribute your objects. Right? And we already talked about what the issues can be. Wrongly modeled, too narrow, too big, whatever, doesn't fit in your domain process, and so on and so on. But if you have to distribute models, that's already a red flag waving at you. Something I also regard as a red flag nowadays is CRUD-based services. If you create APIs, or if you distribute an API and you create CRUD-based API calls, like I want to create this, I want to update this, and I can basically update everything I want. There's an object behind there, a table, I don't know, something, and it has 20 properties, and I can update 20 properties whenever I want, right? This, you have to, what do we want to achieve when we create a boundary? Like, when we create a boundary, what we want to achieve, we want to make sure it's secure, right? We want to make sure that this is, like, nobody can actually do stuff I don't want. And if I create a CRUD-based service, like what I'm basically doing is I'm throwing keys to the castle everywhere. Like, right? So because you're putting the responsibility of using this thing right completely to the outside. Right? Now everybody who calls this has to apply to the rules. They have to know the rules. Right? And if you change the rules, you have to tell everybody. And trust me, you will forget someone. Right? And they will. Right? And if you allow them to break the rules, they will. Just as I said before, why are we doing this? Because we can. Right? So, and again, this is it's a concept. We are trying to model behavior in a sense that you say, give me an order, and I will do it for you. I will make the appropriate updates. I will take the appropriate actions, but I don't want you to know what those are. Like, so we should have very domain-focused APIs. Right? Do this. Like, mark this thing as, I don't know, as sold, as booked, as whatever, right? Very domain-specific, and I then, on my side, in my castle, I can decide what I want to do, right? And again, when you do this, this is the idea, right? We are experimenting. Who needs a key? Who actually is talking to whom? And those, when we can do this in a monolith, like we have this comfort of we can experiment. We can move boundaries. I'm not saying it's easy, but it's simpler than changing those in a distributed way. So, and then we end hopefully with this module-based thing that I call a Modulith. Right? So, boundaries are hard. Like I said, that's just how it works. And again, don't think it's not okay. Like, you will get it wrong at some point. The thing is, put yourself in a position where you can actually fix it, and where you can fix it with like not that much of an effort, right? And experiment with boundaries, and because as soon as you distribute, boundaries are even harder. That's just how it works. As I said, horizontal layers most of the time is a solved problem, because when you use frameworks and stuff, focus on the vertical ones. Right? Really try to be very, very strict about it, right? And write rules for it. This is basically what your reviews and your discussions should evolve around, right? As said, we don't want to talk about, oh, this space is wrong, or this bracket is on the wrong line. No, we want to talk about stuff like this. Like, should you access this? I'm not sure it's okay if you use that object over there. Like, maybe don't do that, right? So really try to focus on the vertical part of your application. Distribute only if necessary, right? We can always do it because we can, but again, if we do this, distributing means adding complexity. And the question already was like, oh, does anybody know how to reduce complexity? Yeah, we know. Like, we can like stop distributing and like maybe putting stuff back together again that belongs together, and that doesn't have to be distributed, right? And then you can enjoy the rainbow cake. Thank you.
Thank you. So we now have, again, time for a little question. If we have a bit of sound. Check. No, we have no sound. Ah.
Thank you, Sebastian, for the great talk. One question, though. You said that every module should have an API to talk to other modules or to interact with other modules. Would that be another horizontal layer?
Yeah, I call it an eggshell around the module, right? It's like you can talk to the eggshell, but only to the outer shell. And it may happen. Like, I would really love to if it happened on one single layer. That would be amazing, right? If you have your business domain and it only happens, like the communication only happens there. But sometimes stuff is like set up differently. And then again, just try to not to communicate with the internals of a module. Try to make it explicit that you are now providing that functionality to the outside world. And that's basically when you build the API to actually do it.
Because most of the time in graphs like yours, the integration layer is also the UI layer, for example. Because mostly the UI is not distributed among modules. And there's a small layer underneath to talk to the modules then, or to get the API, the UI records out of the modules to render it, for example.
On the front end layer, you mean?
Yeah.
Yeah, that's what like frameworks, like front end frameworks, sometimes do.
Yeah.
Yeah. It's similar, I would say, but not like because they are also it's more for me. It's always more a technical thing. Like they are building the modules on technical functionality. That's fine. What I'm really interested in is the usability module. Right, the thing that where can I say, okay, this functionality doesn't have to talk to anything else, and then that's perfect for me, right? And sometimes that's 3 or 5 or 10 technical modules, like technical stuff. Like I said, this is why micros sometimes get misinterpreted, right? Because if the use case is huge, right, and that's the stuff that we build sometimes. Sometimes it's better to have like a huge thing and have it very clear in front of you instead of like 100 small thingies that you don't know how to connect to.
First of all, thank you very much. One of the best talks I heard in person. It was very nice. Second thing is, my question is, you have probably created many services in your development time, and you have seen people creating it. Still, to this day, if someone like there is some task that you have to do, how do you decide? It's not one general answer, but what is the situation where you decide, yeah, okay, I have to create a new service for it, or no, I think this is not the use case for this. What's some advice from your side on this?
So my default is always not distribute. So you have to, like, if I have a monolith, like I put my crawls in that thing and defend it with everything I have, right? You have to have really good arguments why you want to distribute, right? And like I already gave some of them. Like if you can foresee that you need to scale that thing differently. When you see, okay, no, this has to like support thousands of users, and the rest of it just like hundreds or something. Then okay, fine, let's extract it and make sure that it works. Sometimes team structures or company structures can be an argument for that, but I don't really like that. I always, like if people come to me and say, okay, because that's a different team, they have to have their own code base, then I refer them to our app developers, where 100-something app developers work on a single app. Right? And then I say, okay, like if they can do it, why can't you? Right? And they are deploying like every week. Like every week there's a new native app in the App Store. Like, and sometimes even more with hotfixes and stuff. Like it's not a team problem or like software distribution problem. It's an architecture problem that you can solve by modularizing stuff within your code. So the reason can sometimes be different technology. Right? Like, of course, a PHP is amazing and can do everything, right? But maybe somebody comes along and says, yeah, but we need some other stuff. And then you can say, okay, I don't want to introduce this complexity into my monolith. Then I want to say, can I do this? Can I extract the functionality that would need this and could build it externally and then use that technology and that functionality? Also, last resort in terms of do we really need this? But yes, could be an argument for it, for example.
Thank you very much.
So I'd say one last question.
Knowing you have a bunch of teams and dozens of technologies, did you try this with just like one specific technology, or did you try it in multiple teams? Like, were there different outcomes?
So we are in different stages, in different. Some are still distributing, like the big ball of mud. Some are already like reintroducing and recombining services together. And I would say it's a mix of completely different technologies that are in different stages. So we have a lot of PHP teams, of course. They are in, most likely, they are in currently the state deciding how to distribute, or if we should distribute. Or they are already in that stage where they say, okay, no, we totally messed it up. Like, let's reincorporate some stuff. And we have other, like, for example, Java. Like, the enterprise stack currently is heavily microservice, event-driven, and all that stuff. And they are in a process right now. Yeah. I would say it's fine. Like again, you will never get this right the first time. The only thing I can say, just don't distribute too fast, right? And we made this mistake maybe a couple of times.
Speaking of getting things right, what's the status of the Captain Hook elephant?
Nee, I wanted to wait until UnConf to tell you, but there's a prototype on the way. Maybe next year, maybe, I don't know. Let's see.
Okay, there's one really last question, and then we'll have a break again.
You can have your cake.
No, we have to go through another talk, and then we have cake.
Ah, okay, yeah, sorry, I'm sorry.
You don't have a single spot.
Oh.
When I worked in your company, we discussed all the microservice problems, and all the other programmers got the idea to separate the system. We've got a monolith, you know it. We've got the monolith, and they want to separate it by the knowledge about the technical problems. A microservice for PayPal, a microservice for this stuff. And I offer my solution, and I told them we should separate the system into the states of the user interaction. I told them let us make the page, the first page, and the landing pages for them to separate. And then we should separate the search, because in the search we've got no contract. And when we got no contract into the search for our project, we don't need a customer. And then let us separate a service for the contract generation.
This is basically the same approach, right? This is really like focusing on use cases, and I know the team and I know the software, so they are now kind of moving into that direction, kind of. But yes, and like I'm out a lot talking about stuff, but like that doesn't mean everybody's listening to me. So what can I tell you? Like, if they would, that would be amazing. I could like just do it like this, and they would say, "Okay, yeah, sure, Sebastian, I will do that." Like, and I would feel good, and like maybe some things would be different, like maybe horrible in another way, but yeah, who knows? But no, that's not how it works. Like I don't have that kind of power, sadly. I wish. I wish.
Nobody wants to hear that from me, because that's why I leave the company.
So, thank you, Sebastian, for your talk.
My pleasure.
We have a 15-minute break, yeah, and then we will hear from Anne. So,
Nice.
see you later.